its power just tremendous. Like it's black magic or something.
What was the winning technology?
I'm just showing here to the camera.
Three, two, one, go! Hello everybody, and welcome to Hackademia podcast, where our goal is to make complex ideas simple. And today I have a great pleasure to present you one of the youngest quantum technology professional. He's a student of data science and knowledge engineering, recent champion and winner of IBM Quantum Challenge 2019. And I think the best description, at least for me, a visionary data scientist, Lucas-Andreï Thil. Welcome.
Hi, thank you so much, Rubio, for having me here today. What a great opportunity! And
Lucas, I would like to start with getting us ready in the mood. So, quick questions at the beginning to see on what data science spectrum are you.
Okay.
I ask, you respond very quickly. Programming languages, Python or R?
Python.
Mathematics, classical or quantum?
Quantum, of course.
Getting the championship in data science or in fin swimming?
I think that fin swimming is already done, so I should go to a new arena, and I will go with the data science for this one.
I can see that new is always better. But I've structured it a little bit just to play with you, because what I'm really interested about, how you made the connection or being so devoted to fin swimming in your young ages to decide, okay, I want to dive into data science. Where is the connection?
Yeah, what happened here, right?
Exactly.
Okay, yeah. Like first, I think that not a lot of people actually have a clear picture of what is fin swimming, or just maybe right now thinking, yeah, what the hell is fin swimming? Like, okay, we just know swimming, but fin swimming, what kind of weird concept is that? So for the people who have no idea about what fin swimming actually is, it's like you just think about normal swimming, but instead of just swimming like normally, you will like use a monofin, and like a pretty big one. It's like actually quite heavy, and it is either made of glass fiber or carbon fiber, and it's like quite big, and it is like the best tool that you could use to like just move in the water. So it's like very fast, and it's not a sport that is very well known here in the West, like more in the East, like Russia and China. And so yeah, how to answer your
And Lucas, is the monofin the thing that make you look like the mermaid? So I have the one leg and I can swim.
Yeah. Okay, I think you just gave like the best picture actually that we could have for fin swimming. Yeah, so like fin swimming, to just make it short, is doing some like mermaid things, but inside a swimming pool. Yeah, that's, I think, the best picture. And now to answer your question, how did I came from fin swimming to a data science? Well, I think we have to like go back in time a little bit. When I was, I think, 5, like I just had this dream of like, I don't know, becoming an astronaut, because it just like looks so amazing, I think. And it was also at the same age, so there might be a connection here, but I'm not sure. It was at the same age I saw for the first time Star Wars, so I was like, okay, what should I do then to like become an astronaut or a Jedi Knight maybe? But yeah, I choose like to go with like something more realistic, of the astronauts way. So I was like, okay, what can I do, like in this process? So
instead of diving into not gravity place, just dive into water.
yeah, because actually in the process of becoming an astronaut, like, yeah, they are all training in a swimming pool, and I was like, okay, then I cannot start diving yet, because I need to first start to know how to swim. So at 5, I started, taking some swimming lessons, and then at 10 I started diving also, and then I think at 11 or 12, like I found like this sport that is like exactly in the middle between swimming and diving, and it is fin swimming, and there's a lot of like of technical aspect, what is actually the best fin that is like the best suited for your race. And so yeah, I just like got into this sport to like have like the both swimming and diving into like one, and then make a lot of competition out of it.
Progress with this area. But do I understand correctly that the space and being an astronaut is even bigger passion than swimming itself for you?
Yes, like basically we could say that I always like did sport, and especially a lot of fin swimming to develop like some skills that hopefully will be useful if like indeed one day I could hopefully become an astronaut. But we see like that the space industry is growing bigger and bigger, so I think like there is like more chances today, and the future is bright. But like for the skills in fin swimming, I think like there is of course like being at ease in the water and knowing like a lot of technical aspect. But I think there is also like the mindset and the spirit that you need behind it when you do a lot of competition. How do you get like in the national teams? Not like you do not tell yourself, yeah, I wanted to be in it. Like you have to put like all of the work behind. There's like the work ethics and this kind of things. So I think like it's really important, like for a lot like of people that are going to the space today, that they have like clear mindset about what they are doing. And for me, like doing competitive sport was actually, I think, the best idea. To have like a very good mind that can like work in pressure, achieve a lot of things, and at the same time, having like doing some sport, but not really to stay healthy, to be honest. And of course, like this very technical aspect, like just with the gears we are using, but also all of this part about the body, how do we train, because it's not the same every day. And all of this science, I think, like it could be applied to other fields such as the space industry. And like the logical step was, yeah, at some point you need like to stop it and move to like, what's the next step, So this is what, so I thought that artificial intelligence might be like one of the best tools, to solve a lot of critical issues that we have.
In the space mining and in general,
Not just in
the
space, yeah, but like also in a lot of different fields, like even in agriculture, in politics, or like just computer things, or maybe hopefully one day coming with like a more general godlike AI or something. But I just thought it's like a wonderful tool that we can really apply everywhere to like solve some like task better. And of course I could also use it in the space industry, but also in many different fields. So for me, it was like the best choice to do right now, and especially in the sector today. I think like it is the place to be right now. It's like the good thing to do at the right moment. So for me, it was a quite obvious choice to come here in Maastricht University to study this.
So let me ask another question, because I can see more about the connections in your life, but I see another connection: the quantum world and the quantum technology and data science and artificial intelligence in general. How those two are connected in your mind?
Yeah, because like why is there such a hype right now, like fields such as AI? Because like if we think about it, AI is not something new. Like we had like Alan Turing is considered as the father of AI and everything. We get like some chess AI, this kind of stuff. So
yeah, the algorithms exist for, well, at least for the ones that we use right now. Most of them exist till 80s, but the Turing machine was much more earlier.
Yeah, so why do we have like such an interest right now with the AI, and like the answer is that actually we have like so much computing power. Like there is like Nvidia, for instance, like they just make like huge and amazing graphic cards. We could even like think about last week Tesla's presentation about the new chip to like for their self driving car. And the case like there is right now a huge amount of computing power. And if you look at quantum computers, the computing power that we have here is so big. We cannot even like just picture it correctly. So like maybe not right now, but in a near future, we could like really expect to have like way more tasks done effectively on the quantum computer, just because like its power just tremendous. It's like it's black magic or something.
Okay, so if we have so fast technology and right now it's made to the public, tell how you win the competitions connected with that. For what you get this wonderful trophy.
Oh yeah, this little baby here, right? Well, first to give some context, maybe like yeah, what was this challenge? So basically, yeah, right now there is also a hype with the quantum computers, and there is like this amazing company which is IBM just made like a new quantum computer which like looks and works very awesome, and it's like the most powerful quantum computer ever. Like just to picture you this, if you take all of the computers in the world, just put together, this new quantum computers from IBM is like way more powerful, which is like just mind blowing. And so to like present this new idea, they decided to make this quantum computing challenge here in Maastricht with the collaboration of our amazing university. And so they made this challenge. So we got some introduction on how a quantum computer works, which is like the concept itself is just mind blowing. And so basically everyone were put in different teams, and we had literally a white card, and the idea was like, yeah, do whatever you want and just come up with an idea. And we had like the final presentation this week on Wednesday. And so, what was our idea?
What was the winning technology?
Because the Mister here was also in the team. Please know that there is not just me. Like this gentleman here did a lot also.
All right, all right. I also participated, but for today, I am the curious person that knows nothing about quantum, or maybe a little bit. I want to ask questions today about the idea. What was the winning technology?
Okay, so like yeah, we needed to come up with an idea that was at the same time could make huge improvement using the quantum technology, could be reliable, also yeah, like let's be honest, had quite some money opportunities in it on the long term, because like we want to at the end use it, right? So basically, our idea, because we have right now so much computing power, and we just ask this question: yeah, what if we could push the limits of design? Right? What is the next step? Because right now, when companies are trying to come up with the product or a solution, like everything really like the solution goes into the design. If they can make like a very compelling product that is like really good and like has some quite insane specifications, then like it can solve a lot of issues. So our idea was like to make a generative design algorithm. For those who don't know what generative design is, like basically you have your computer and just like tries to find the best possible shape ever, taking into consideration some parameters. So we did that on a quantum computer. And what is like awesome about the quantum is that because of all of this power, you can like work on very, very small scales, right? So for instance, if you take like, I don't know, like let's just take this object here. If you like zoom a lot in it, you will actually like not see something smooth, and soft. You're actually going to see like mountains and stuff, and it's like it's bad. It's not optimized at all. Like let's just say it. So what if you could already optimize things on a very very small scale? Like just imagine like it's going to be like 10 times lighter, such that on the big scale you are going to have like something that is way lighter, cheaper, and stronger. So this was like the main idea. And
So let me ask a question. Are you using also machine learning technology for the solution?
yes and no. Yes, because like it's not right now yet optimal. Like there is still a lot of work that we need to do on this matter, but this is definitely like one of the things that we need to solve in this process, because there is like so many different things to like compute and everything, even on a very small scale. It's like kind of very repetitive, and there's like a lot of math behind, and it actually fits quite well the idea of machine learning, to like just have a pretty repetitive task and just do it again and again and retry to optimize everything. So yeah, there is like machine learning is very important in it, especially because, and this is like awesome if you think about it with the quantum computing, is that there is so much power that you could literally in a structure try to simulate each single molecule in the structure to find like even which one might be the best. And also this is like, this I think could just be done through a quantum computer and not like a normal one, because if you think about it, nature doesn't work with like bits of 0 and 1, but it's like it works with the quantum physics, right?
Right.
And quantum computers work like the exact same way. So if you want to like really fits about like how our world is working, you should like take those same principles in your like a design process. So quantum computers, like I think the most obvious solution for this kind of design problem. Yeah.
But to simplify a little bit the machine itself, I wonder, because we are getting on a very deep level with how to optimize the structure itself. And with this, the bigger computational power we have, the more precise structure we can talk about. But how the machine learning machine works? What is the input? What is the output? And what is actually our machine doing?
Okay, yeah.
On this example, for example, I want to create a trophy like that. How do I play with your machine, with our machine?
Okay, yeah. Okay, let's just like take this example that we want to make a very and beautiful trophy. Like this one is like this gorgeous trophy, right?
Yeah, it's just an object. How do I optimize it?
Okay, we'll just make like a mind demonstration about how our algorithm works. So okay, you want to like make this, okay?
All right.
Okay, what do you see here? So we have like this, like this main support here, and okay, so you want like something that has like this kind of shape.
Yeah, probably strong to like sustain everything.
And most of the trophy, like they're like quite thin here, and then they just like go thicker here a bit. So it's like it's like a
so
flying
it will
like
be able to handle it nicely.
yeah, and you want here to have it a bigger, for instance. So basically, you will like just tell your computer, okay, here and like I just want like this kind of shape here. Then here I would like something that is like quite thin, and then something bigger. So with that, you could actually parameter some a design space, some kind of outside skeleton for your structure here.
So can we say just a sketch of the creative person?
Yeah, more or less. Like it just basically, we just like make some bounds about like where the algorithm can think and try, and then we'll just press start, like literally.
All right. Start.
Okay, boom, start.
Machine takes. What's happening?
So right now the algorithm will like try to find like a different a combination of the structure, but at the end you want the best one, right? I mean, we don't like do all of this to have like something bad. Like we want the best one, right?
Yeah, but what do you mean by best one? The most beautiful one, the strongest one, the cheapest one?
Yeah, true. Because how can we define if a structure is good or not? So like, okay, we like just imagine that we want a very strong cup because like we want to a party with it, you know. It's going like, okay, we won't go into too much details, okay, but like, yeah, you want like a very strong cup that is also quite light, and I don't know if we want it expensive or not, but yeah. And basically, the algorithm will like try to come up with like all the possible shapes that this cup could have, and then it will like apply some test if like to see, okay, is this cup strong? So we have like some algorithm that can actually find some weak point in our structure, and if like there is a weak point, like let's just imagine here, the algorithm will like try to solve it and make it stronger, for instance. And at the end, like we have like a lot of different design of the cup, and each time we just select the best ones out of it. You know, like the ones that are like quite light, strong, and we like just, you know, keep this looping over and over with every time our best structure until we kind of reach, you know, an optimal solution about like the best design of cup that we could ever have. So this is like the, the main idea of this algorithm. And
So I understand the machine is like taking the most optimal structure. Or let's say if I have like points connected, it will take the shortest path of the connection of the points. But what is the output then?
Okay.
If the input was a creative sketch.
Okay, yeah, because we like have to like take in mind that everything is done like through some computers, you know, and we also want to like see it. So we also use some 3D modeling software to like kind of, you know, show how our algorithm is like thinking and seeing, right? And,
Right.
and at the end, when we reach our final solution, we literally like can just transfer it and like save it through an STL file. So what is an STL file? It is literally the type of file that you just put into a 3D printer. So like there is like just one click from your optimal solution and having it here in reality. And this is here actually what we showed during our final presentation, because we wanted like to, you know, have like this case example of with the motorbike. So like I'm just showing here to the camera, like just try to imagine that this is actually a motorbike. Yeah, I know like on the first try it's like quite hard, but we can imagine that we have like the steering here and like something that could move here with like the back wheel, and you know like where people could like sit here or something. So like this is the like the test example we show during our presentation, and as we can see, it's like it's a bit optimized. It looks kind of weird, you know, like
It looks super weird.
yeah, like some bones or something. But yeah, like this was like one of the first try, maybe one of the first structures ever made on a quantum computer. I'm not sure, but
Yeah, but I think beautiful thing about this technology is that we can get from the era of mass production into era of customized production with mass optimization. So we only keep the optimization part as mass produced by our machine, but actually we can make the products that are customized for every person that wants, we can fulfill every need with it. Yeah, and you start talking because, yeah, we can have it as a bike, but imagine that instead of a bike, you lose your bone, and we're looking for the most optimal shape that would be durable, cheap, and will last very long. So imagine we'll just print the bone in that will go into your back or in general into your body. And this is the nice topic that I would like also to talk with you about. What application of this technology do you see in the future?
oh, there is like like a lot of them, because like a design, there is a design ever, like just right now we can like just look around us, and everything was like thought, and design. Okay, like what, how should it be? But you just mentioned the example of medicine and bones, and I think like this is like one of the boldest example that we could have, because if we think about it, all of our body and bones are actually the some results of optimization. Like, okay, like how the bones in our arms are, it's like it's from like thousands and thousands of years of evolution, so like really come like the base shapes of bones. And like if we like look at this again, it somehow looks like a bit like bones, even if like the final shape is not perfect. But yeah, like it's like the principle of our algorithm is like more or less it works the same way as bones are created, actually. So yeah, there is like first this application in the medicine, like we could like literally know if you like lose your arm or something, we could like make some very similar repairs about how your arm looked before. So a lot in robotics with all of the optimization. But we can also think about fields such as architecture. If you want like to make like a big building or something, like nice and futuristic shapes that are also quite cheap. Like this is a good way to go. Like there is a lot of people that are homeless today, and if and they go, okay, how can we build something that is cheap, good for them, because like you don't want to like live in some crappy location, right? So like we could literally come like some housing for people, and at the same time it will even look good. So I think there is like quite a lot of application in this. And the think the biggest one is of course in engineering, because this is where like you need as much optimization as possible. In term, if the design is like is performing well, if it's like cheap, if it can go into mass production also. And because we can like 3D print all of this, like anyone that has something broken could literally like just either take the same and print this at his place, or just try his own thing. So at the end it's
Yeah, imagine it would be not only as a repair thing, but imagine you are just sitting on your couch, it's Saturday, you are bored and you think, oh, maybe I could get some new couch, but you don't
Yeah.
want to,
Yeah.
get to the shop and do the stuff. So what? You get your magic pen, you just write a sketch where, yeah, you create the perfect couch that you want to lay all day. You just send it to our program, you press the button, then you have the most optimal shape created
with quantum computers. And this is
with
awesome
quantum
because
computers.
like if you just think about it, because yeah, like the 3D printing industry, it's like the goal is like to really bring this in the homes of everyone. But now, like we could not just bring 3D printers in the houses of everyone, but even quantum computers. If we think about it, like everyone could like use the quantum computers capabilities to print their own shapes and everything, and then everyone could like have this. So it's not just about some very like some general mass optimization, but it also goes into the very individual level at the end. So like it's really like, as I said, like can touch and cover pretty much anything you could think about.
So Lucas, let me, as a quantum freak, I would like you to ask a question or a favor. Can you give me the application of just quantum technology that go even beyond our quantum machine learning generative design?
Oh yeah, because yeah, this is of course like just one example, but a lot of research and algorithm were already made to tackle other sector that are more that needs like some computing optimization. We can think about the finance in business in general. You know, how we can like come up like a better solutions also with the
For example, in high frequency trading? Or?
yes. There is already some algorithm that are doing this kind of optimization, but I'm confident that this is going to be even better in the future because quantum is starting right now. You know, like it's just the beginning actually, but there is also like we could think about some other stuff, yeah, as you said, in machine learning, for instance.
Machine learning in quantum technology. It's possible to use like algorithms like, I don't know, neural network, like holistic gradient reinforcement learning. Is it also, let's say, quantum versions of those algorithms?
Yes, there is already some like quite of couple like a couple of machine learning algorithm. There's like already some classifiers, this kind of things. But right now they have an issues that we cannot for the moment like give them some large data set. Like if we like if we get like one that has like 20 different elements, you know, it's kind of, you know, the best you could do more or less. And with the normal computers of today, we could like have like literally some insanely big data sets. So like there's, but you know, there is like still a lot of work.
Yeah, it feels like 80s again, that we have algorithm, we
Yeah,
have
yeah.
some hardware that is not perfect, and we still have to wait 20 years to create the artificial intelligence revolution.
Yes, but it is going to be worth it because at the point we'll be able to like import a larger data set. Like just everything that you could do is going to be so fast because the principle that on how quantum computers works is actually, you know, way like, okay, we're just always saying, yeah, it's faster, faster, yeah, but how faster is it, right?
Yeah.
Like if we take just a normal search algorithm on a classical computer and we just like think, okay, it has a like a worst case running time of n, which is good, you know, like it's like pretty good in some applications. Um, on quantum computers, like the same time that is on the classical one, n is going to be square root of n in the worst case scenario. So if your like classical search algorithm takes 100 seconds to like find something, the same algorithm will take the square root of 100, which is 10. So we go from 100 to 10. This was like just a very small example. And in the worst case, because in the best case, like, you know, like if you think about it should actually be impossible, but it is possible.
Okay, so get your belt fastened. I want to ask you this. You have the quantum technology as it is, the fastest thing currently on the market. What is the craziest idea using this technology that you could imagine?
It is a very hard question to answer because it is like just starting right now. For sure, it will be something with where AI is going to play a part in it. Like I don't think anyone can doubt that. But then, yeah, okay, like what is the craziest thing? So we have AI, a lot of computing power. I think it's not going to be in just like one field, but you know, it's going like to really touch and disrupt like many things, you know, like the lives of everyone every day, you know, because like it's just going to be so big. I think it's going to be like a combination about how our societies work, how we see things, approach them, and it's too soon to like tell it. Maybe we might know it like at the end of this century. But what is the world going to look like, you know, in like 100 years? So everything is going to be so different, and we cannot have
depicted
it.
in Black Mirror, maybe.
Yeah, but most of the time it's not ending well. Am I correct?
That's true, but you know, well, in my head right now, I have the vision of the episode with the bees, the
Mhm.
Black Mirror episode when there was technology. You were saying one very fast computer, one using artificial intelligence. I think about the one super fast computer that can be managing millions, let's first say hundreds or thousands of bees. Bees that, they can then manage the management of plants, so they know exactly where every plant is. And I know in Black Mirror it ends very bad. However, why don't we make the idea good?
Yeah, let's just try it, just to see if we can have a different outcome.
Yeah, but would you say that, I'm describing right now, something that is just an idea, it's just sci-fi. Is it possible to make it with this technology, in your opinion?
Yes, I think so, because like if we can just imagine, like, okay, like if we think about, well, okay, like let's just like, okay, I'm even asking at the camera here, just think about a robot. Okay, like you have a robot in front of you. What is this robot? Okay, like it's most of the time big, it's not moving very well, it's like it sucks. Like let's be honest, like it's big and then it doesn't move fast, because inside of them, like they have a lot of hardwares and computers, and this take a lot of space. So what if we could like just get rid of the computers inside, and instead we just like have one main computer that can manage, this robot, and we just imagine that this computer is actually a quantum computer, because it goes fast, but because it has a lot of computing power, we could like even manage not just one robot, maybe 10, 50, 100 or more, and they will be quite agile also. So let's go back with the example of the bees. Let's just imagine, yeah, we are, for instance, a farmer, okay? And okay, what do we need to, for like, I don't know, we have like, we are cultivating tomatoes, for instance, like we have a huge fields of tomatoes.
All right.
Okay, what do we need? We need like, okay, some machines like tractors for instance. A lot of farmers are also using some chemicals, because it's like hard, and it's like it's a very tough job, and they need to like use it to just have money and to survive. But this also
lots
costs a
of
lot.
fertilizer,
Yeah.
lots of water, lots
Yeah.
of
Yeah, and with the water and everything, and even with all of that, they're not even sure if they could make it, and they already spend a lot of money in this. So like, let's just imagine we just get rid of all of that, and this farmer like just have, I don't know, like 50 mini drones that have like the shapes of bees, for instance, that are all connected between each other, like one main computer, like one mind, and 50 bees, and he will like just send those bees into his fields, and they will like just go from like plants to plants, put some water. If there is some bad insect, they will like just, get rid of them in the nicest way as possible, but we won't use chemicals anymore, so the soils are like preserved. And at the same time,
and if you use a little bit of fertilizer, then you are using just the perfect amount for each plant, and you are
yes, absolutely. It is optimization again, and because we are just sending all of those bees, and they're actually all one mind, they will like all have some sensors or camera or something, and so like, just imagine that one bee go into one plant, they check everything, put some water, check, how many tomatoes there are, and they could like literally, make at the end a full map of all of the fields of each plant and each tomato on them, and if they are good, how big they, they are, these kind of things. And at the end, we could like take all of this data to like make then some prediction, what we need to change, what, how is the field going, or if it's going to rain, how we should adapt ourselves. And with all of these predictions, our farmer could even, knows how much is going to make this month, where, what's the situation, and this is just by, investing in those bees. No like expensive machines anymore, no more chemicals and this kind of things. So at the same time, we can we can like help people that are doing a very tough but very important job, and at the same time fighting some climate change issues about saving our planet. So I think like it's really a win-win situation. And just thinking about it, I think yeah, like it's the right way to go. Like I don't want to like stay with like the old way of doing this kind of thing because they are bad.
Yeah, well, I think if the architecture of it is controlled, then yeah, it's the person who is creating it that's made the bad thing. If you understand it, you cannot make it bad without purpose of making it bad.
Mm-hmm.
So yeah, you have to have bad people also to make this idea bad. But I think
we will fight them, okay?
Yeah, I think with the proper regulation and with proper software engineering, you can get rid of the risk, the danger risk of using it in the evil way.
Yeah, and this was like just one example because I think the main idea was about quantum. Like okay, there's a lot of like scientific and technical things, but actually, the only thing that really matters at the end, and this is why people are like working in like in AI in quantum and these kind of things, is like just simply make the life of people better and like improving our world. Because if it is not to do that, I think there is no meaning, to do this. And we finally like have this window of opportunities open to really like do this. We have like so many tools, and I think like right now is the moment to do it. We
Right now, the window opportunity is open.
But it is not just an idea, or just some dreams. It is even a necessity because like in those trying times that we live in, like we need to do it. There is no other choice. It is either going this way with like growth and these kind of things and preserving our climate, or not doing anything, ending into a bad way. And like maybe we won't even be here in like at the end of this century.
Okay, Lucas, but let me ask you a technical question. If it's possible and it's a necessity right now, how can I use the quantum computers? Is it possible?
It's quite hard, but there is already a lot of initiatives. Like the best example is like
Yeah, imagine I am the machine learner and I want to test the quantum technology. What do I need?
okay, uh, there there needs to be like all this quantum world, kind of needs to be more open and more accessible to people. But there was like we mentioned this earlier, like this very generous opportunity that IBM made with this quantum challenge here in Maastricht to allow more people to like get in this. And like I'm sure like it did its job. There were like a lot of people that right now want to learn more in quantum computers.
Yeah, but how they are enabling their hardware and software? Can you use, for example, IBM computer, quantum one?
Yes, we can, but I will say that right now there's not a lot of interfaces, these kind of things to use them, and we basically actually need more people to like get in this, like not just things as like labs, papers, but like a lot of people. Like we need engineers, professors, students, but also like very really sharing this passion about this.
The libraries accept QSKit because yeah, to make the little perspective, IBM also beside accept the quantum computers that they are enabled on their website to approach. They are also using the QSKit library, which is the quantum library for in Python. However, I feel that what is struggle if you first touch it, you see that there is so little community right now that needs to grow just to work on the by the scale of people coming into the area. They are making their contribution, and then we can grow also in that.
Yes, because so as Rubio said, like Quizkit here is like the best way for the moment, use quantum computers, but it is not yet optimal. It's like it's hard, no? Like it is so hard, like just to do some very simple tasks. It's like just insanely hard. So there is like a lot of work to be done this way to make it like work better. I mean, there are a lot of people to develop like those algorithm that everyone could use. So yeah, like because right now, it is just starting, and we need to like make it happen to like create all of this environment to do this kind of things at the end. So right now,
Everybody get interested in
yeah,
quantum
please,
technology.
quantum computers need you.
So, Lucas, at the end, I have 3 questions. I started with quick questions. I would like also to end with quick questions. Tell me the technology that we all should pay attention right now.
Oh, okay. I will go with the AI in general, whatever
And not quantum.
AI on quantum computers. But I think there is like a balance between the classical computers and in the quantum ones. But the quantum ones are going to grow quite big. But just side note, I will say pay attention to all of the technology that can touch about trans humanism, or how to make like super humans with like better capabilities. I think like this is like even maybe more dangerous than AI, but this is for another time.
So super people. What are the not super people but normal people that right now are changing our world in your view?
Well, I think that everyone at the end just someone normal. I don't think that you are boring. Better than someone else, and it's really like what you are trying to work on and achieve that is very important. I think my answer is going to be like quite trivial, and like I mean, because I would say that Elon Musk, is like this big figure about what is happening right now in the world. Like there is of course a lot of other people, but I think like he's the one who is like the most into like involved in all of those things, like space travel, climate change, AI with like yeah, oh my god, like it is just something. Yeah, so I will definitely go for him. Yeah.
All right. So last question. Tips of how to start a journey with data science.
Oh, tips. I will say like yeah, the most basic things like get in touch with like programming in general is like quite helpful to help you shape the way that you think about some problems in general. Like well, it's all of the algorithm, but mostly how when you think about something you could make it better in data science. I think it is just that it is applying some mathematical concept to then find the most optimal solution and even make some prediction and these kind of things, or just simply be curious about things, I would say.
All right. Thank you very much, Lucas. And if you're interested in changing the world of tomorrow, you can subscribe and like our podcast. And if you're willing to discuss wonderful ideas, for example, the P of the futures, you can leave a comment. And here on Hackademia, we're going to try to simplify it as much as possible, but not within the complexity of the problem. And let's make complex simple and democratize artificial intelligence together. Thank you very much.